Hello and welcome. Whether it's the feeling of the sun on your skin, the sound of rain on your window, or the sight of clouds drifting across the sky, our lives are woven into the fabric of the Earth's climate. It is our home, our life support system, and the most complex and vital force we know. But this system is changing. You've heard the headlines and you've seen the reports. It can often feel confusing, overwhelming, and distant. This content is a guide through the noise. Welcome to Our Living Climate, Understanding Our Planet and Our Place in It, presented by the My Name is Climate Foundation. Over the next 20 chapters, we will embark on a journey together. We will start with the fundamental science of how our climate works, from the energy of the sun to the depths of the ocean. We will then trace the human impact on this delicate system and survey the evidence that tells us our world is changing. We will face the consequences of these changes, and finally, we will turn to the hopeful, innovative, and essential solutions that are already within our grasp. Our goal is not just to give you information, but to build understanding. By the end of this journey, you will be climate literate, equipped with the knowledge to engage confidently with this critical topic, and empowered to take responsible action in your own life and community. Our story begins not here on Earth, but 93 million miles away, with the star that powers our entire world. We now begin with Chapter 1, the Sun, Earth's ultimate power source. Section 1.1, a morning greeting.
Imagine the start of a new day, whether through a window in a bustling city or across a quiet, misty field. The first rays of sunlight slice through the darkness. You feel their warmth on your skin. You see the world illuminated, colors shifting from gray to vibrant hues. A plant on your windowsill, which seemed dormant through the night, begins the silent, vital work of turning that light into life. This daily experience, so universal and profound, is our most direct connection to the single greatest force shaping our planet, our star, the sun. It is a welcome warmth, a guiding light, and the quiet engine driving every gust of wind, every drop of rain, and every living thing. We often take its presence for granted, a reliable fixture in our sky. But to understand Earth's climate, we must begin our journey 93 million miles, 150 million kilometers away, in the heart of this colossal, fiery sphere. Everything that happens here, the weather, the seasons, the very possibility of life, begins there. In this chapter, we'll explore how this distant star acts as the ultimate power source for Earth's complex and dynamic climate system.
Section 1.2, a star is born, the engine of fusion.
So, what is the Sun? It is a star, a massive ball of incredibly hot, dense gas. At its core, the temperatures reach a staggering 27 million degrees Fahrenheit, 15 million degrees Celsius, and the pressure is immense, over 250 billion times the pressure at sea level on Earth. Under these extreme conditions, the most powerful process in the universe takes place: nuclear fusion. Think of it as the ultimate cosmic forge. In the Sun's core, hydrogen atoms, the simplest and most abundant element in the universe, are crushed together with such force that they fuse to become helium atoms. This process is not a simple merging. A tiny fraction of the mass from the original hydrogen atoms is converted directly into a pure, explosive burst of energy. This conversion is described by one of the most famous equations in science, Albert Einstein's E equals mc squared. This equation tells us that mass, m, can be converted into energy, E. And because the speed of light squared, c squared, is such an astronomically large number, even a minuscule amount of mass creates a stupendous amount of energy. Every second, the Sun converts about 600 million tons of hydrogen into helium. In doing so, It converts roughly 4 million tons of matter into energy. The power unleashed is almost beyond human comprehension. More energy every single second than humanity has used in its entire recorded history. This is the energy that lights up our day and fuels our world.
Section 1.3. The Journey of Light, Radiation and the Spectrum.
Once created, this energy travels from the sun's core to its surface and then radiates out into the blackness of space in all directions. This energy travels in the form of electromagnetic waves, a process called solar radiation. Imagine dropping a stone into a calm pond. Ripples spread out in every direction. Solar radiation is similar, but instead of water ripples, it's waves of energy. These waves are not all the same. They come in a wide range of wavelengths, collectively known as the electromagnetic spectrum. Earth receives a portion of this full spectrum. The most important parts for our climate are visible light. This is the sliver of the spectrum that our eyes have evolved to see. The rainbow of colors from violet to red. Crucially, this is also the primary wavelength used by plants for photosynthesis, the process that forms the base of nearly all life on Earth. Ultraviolet, UV, light. This is a higher energy, shorter wavelength light that is invisible to our eyes. It can be harmful to living tissue, causing sunburn and DNA damage. Thankfully, as we'll see in a later chapter, Earth's atmosphere has a protective layer, the ozone layer, that shields us from the most dangerous UV rays. Infrared, IR, light. This is a lower energy, longer wavelength light that is also invisible to us, but we feel it as heat. When you stand in the sunlight and feel its warmth, you are feeling the effects of infrared radiation being absorbed by your skin. Think of a campfire. You can see the visible light from the glowing embers, but even if you close your eyes, you can feel the warmth on your face from a distance. That warmth is infrared radiation. The sun works the same way, warming our planet across the vast emptiness of space.
Section 1.4. The Solar Constant, a surprisingly steady hand.
As Earth orbits the sun, it intercepts a tiny fraction of the sun's total energy output. The amount of solar radiation that reaches the very top of Earth's atmosphere is remarkably consistent. Scientists call this the total solar irradiance, often referred to as the solar constant. Its value is approximately 1,361 watts per square meter. To put that in perspective, imagine a square space, 1 meter on each side, about the size of a large card table, held facing the sun just outside our atmosphere. The energy falling on that space every second is enough to power more than 13 100-watt light bulbs. Now, the name constant is a little misleading. The sun's output does fluctuate slightly. It goes through an approximately 11-year cycle of activity, marked by the appearance of sunspots on its surface. During a solar maximum, there are more sunspots, and the sun emits slightly more energy. During a solar minimum, it emits slightly less. However, these variations are tiny, less than a 0.1% change. Over the long term, the sun is an incredibly stable and reliable source of energy, which has been crucial for allowing Earth's climate to remain stable enough for life to evolve and flourish.
Section 1.5. The Conductor of Earth's Climate Orchestra.
This constant, powerful stream of solar energy is the fundamental driver of everything we call climate and weather. It doesn't just provide warmth and light, it sets the entire planetary system in motion. It creates temperature differences. Because Earth is a sphere, the sun's rays strike the equator directly but hit the poles at a glancing angle. This heats the tropics much more than the polar regions, creating the fundamental temperature gradient that drives our climate. It drives the winds and ocean currents. The atmosphere and oceans are constantly working to balance this temperature difference. Hot air at the equator rises and moves toward the poles, while cold, dense polar air sinks and moves toward the equator. This movement, combined with the Earth's rotation, creates global wind patterns and drives the massive ocean currents that transport heat around the globe. It powers the water cycle. Solar energy evaporates water from oceans, lakes, and rivers. This water vapor rises, forms clouds, and eventually falls as rain or snow, creating our weather systems and sustaining life on land. It is the foundation of the biosphere. Through photosynthesis, solar energy is converted into chemical energy by plants, which then feeds nearly every ecosystem on the planet. In essence, the sun acts as the conductor of a grand and complex climate orchestra. Its energy is the score, and the atmosphere, oceans, ice, and life are the instruments. Each plays a part in creating the symphony of Earth's climate. In the chapters that follow, we will listen to each of these instruments to understand the roles they play.
End of Chapter 1. The Sun, Earth's ultimate power source. That concludes Chapter 1 of our living climate. We've seen how the sun acts as the ultimate engine for our planet. But what happens when that energy arrives? In our next chapter, we'll balance the Earth's energy budget. To continue listening, please find the complete series playlist on our YouTube channel at My Name is Climate.